Good day, I am Daniela Agatopi Santiago from BS Chem 1-2, and for today, I will going to discuss to you our oral examination for our Score Booster exam, Part 1 and Part 4. For our topic number 1, how does hydrochloric acid works in our stomach? For here, we could see the representation of the video that there is a presence of acid inside our stomach. But how does really that we could be okay even though there is a presence of very strong acid inside our stomach? So as we all know, stomach acid is one of the most important fluids in our body. Excess and lack of this fluid will greatly impact the function of our body system. So here is a representation of our digestive system. As we all know, our stomach takes food from the esophagus or from our mouth, then it will passes through the esophagus and has the function to break down the food as we intake as it circulates within our digestive system. So from our mouth, it will pass through the esophagus and through the stomach and then through the small intestine and then to the large intestine and to the rectum and to the anus. This is the overall process of what we know as our digestive system. So here, the digestive system breaks down the food into nutrients such as carbohydrates, fats, and proteins. Macromolecules are absorbed as a form of energy, growth, and repair for our body. It digests and discarded the leftover as feces. So stomach acid is a first line of defense against microbes and pathogens, such as we consume food daily, right? It makes up strong acids such as hydrochloric acid, potassium chloride, and sodium chloride. So as we all know, in the lining or especially the inner mucous membrane of our stomach, you could find 3 different gastric glands known as the digestive enzymes, hydrochloric acid, mucus, and bicarbonates. In our stomach, we need a very low pH, usually around 1 to 2 pH level. As you all know, there is 1 to 14 pH level where 1 to 7 is the strongest while 7 to 14 is the lowest, which is acidity is 1 to 7, and then 7 to 14 is the basis, right? And then 7 is the neutral. So 1 to 2 pH level is a very strong acid, as 3 to 4 pH level can melt metal. So you could know that it is a very, very strong acid. A very strong acid that can release enzymes to break things down and speeds up the chemical reaction in our body. So the gastric juices are made up of digestive enzymes, in which our body can produce at least about 3 to 4 liters per day. Next is the hydrochloric secretion or the hydrochloric acid secretion. So as a matter of fact, parietal cells in the mucus or in the gastric glands are one of the responsible for secreting hydrochloric acid on the lumen of the stomach. So the energy used for the secretion process is obtained from glucose. So how can the stomach protect itself from this hydrochloric secretion? We're going to discuss first the hydrochloric secretion. So this is the representation of how hydrochloric secretion works. On the right side, there is the bloodstream. And in the middle, this is called the parietal cell or the gastric glands. And this out in the left side is the lumen gland, so where the production of hydrochloric acid takes place. So in here, as you can see, first is that the carbon dioxide gas from the bloodstream will gonna passes through the parietal cells, and it going to react with the water that will form a carbonic acid, which is an H2CO3. But it will dissociated into its ions and became bicarbonate ion or HCO3. negative, and a proton, which is H positive. Then the proton in the parietal cell is pumped out in the proton pump into the stomach lumen. So this one, the red one here, is the proton pump, where you can see the H and K ATP base. So this process consumes ATP or adenosine triphosphate. That's why you could see the adenosine triphosphate here, because it requires this energy to pump out the proton in the lumen gland, or in the gland of lumen of the stomach. Lumen is kind of like the overall coating of the stomach. So while the parietal cells simultaneously secrete H positive to the stomach lumen, potassium ion diffuses passively in the proton channel from the lumen to partial cells. So as you can see here, there is a cycle between the potassium ion, where the potassium ion from the parietal cells will gonna move from the potassium ion channel, and then we're gonna go back or to go to the lumen gland, and then it will gonna be pumped back again to the parietal cell as it passes through the proton ion channel. So a cycle will happen as an active transport pump potassium backs into the lumen through the potassium ion channel. So it will just gonna repeat its cycle and gonna go from the parietal cell to the lumen gland. So the bicarbonate ion, as you can see here, which is the HCO3, will gonna be pumped out through the anion exchanger, which is the red one here up there. In exchange, chloride ion in bloodstream will be pumped from the bloodstream to the parietal cells and will be sent out through chloride channel to stomach lumen. So as you can see here, the bicarbonate ion HCO3 negative will gonna passes through the anion chamber, and then the chloride ion from the parietal cell we're gonna move through the chloride ion channel and go to the stomach lumen. So combining that there is hydrogen positive or H positive and chloride negative in the stomach lumen, we could produce a hydrochloric acid. On the other hand, the bicarbonate ions will gonna diffuses into our bloodstream. So in summary, it's gonna start with the carbon dioxide, will gonna go to the parietal cell and gonna combine with water that will form a carbonic acid, which will readily dissociate into its ions and will gonna form a bicarbonate and H positive. Then we're gonna get two ions in the stomach lumen, which is a chloride and H positive. And then they will gonna react with each other and they can produce hydrochloric acid. That is how hydrochloric acid secretion works. So how does the stomach protect itself from hydrochloric secretion? So how can the stomach protect itself from this hydrochloric secretion? First is that the reason why gastric mucosa isn't affected by the secretion of hydrochloric acid is because the pH level in the parietal cells is neutral. It does not change on its acidity due to its mechanism. Next is that the goblet cells in the mucosa secrete a large amount of protective mucus on the mucosal surface. It also protects our stomach from the secretion on the hydrochloric and digestive enzymes. So if you could imagine that this is our stomach, and in the stomach there is large secretion of a protective mucus in the stomach. That's why the acid inside the stomach will not gonna go out, because there is a protective covering in the surface of the stomach. So mucus and bicarbonates acts as a protection coating as it covers the walls of our stomach against hydrochloric acid. That's why it could protect itself without hurting our stomach, even though there is an acid inside our stomach. happens when there is an excess of acid present in the stomach? How is it being reduced? So as we all know, if there is a stomach ache in our tummy, it will gonna hurt a lot. You will feel the pain. You will feel like it's squeezing your tummy. And this is what it looks like inside. This is what it looks like inside because the acid is moving in our stomach. There's a possibility that it overflow because in here, in between the esophagus and our stomach, there is something similar to like a valve where it could open and close as we intake food from our body. So here is the answers. Excess acid in the stomach will cause acid reflux. So acid reflux is something like when there is something, just like what I stated earlier, right? There is something like a valve between the esophagus and our stomach. This valve could close or open after we consume our food. If there is an increased amount of acid in the stomach, acid might occasionally went through the esophagus and could cause acid reflux. So imagine this is the acid and this is the esophagus. So when we intake food, it could open and then the acid might go passes through the esophagus and we could feel the pain. And we could feel the pain inside. That is what we call acid reflux or acid reflux. Next is the peptic or gastric ulcers. Excess acid will cause peptic ulcers or sores that can develop when gastric acid begins to eat away the lining of your stomach. So when it eats the lining of your stomach, it means that it's something like eating away the protective coating in our stomach. So it will gonna be thin and the stomach acid might scatter in your whole body system. That's why when other people say that when I feel acidic because I drink coffee, I feel like it hits up my tummy and stuff like that. Next is the gastroesophageal reflux disease, or what we know as GERD. So GERD is a condition in which stomach acid reflux was repeatedly boxed up into your esophagus. So acid reflux is kind of similar to just it just happened once, twice, but GERD is something like it happens repeatedly, and you're gonna feel the pain in your tummy. You're gonna feel constipated. You're gonna have a hard time digesting your food, and whenever you eat something that will trigger your acid, it will gonna really badly hurt because my doctor diagnosed that I have a GERD last year, but until now I'm having a hard time digesting coffee. And there are a lot of foods that we need to avoid so that it would not be much more worse. It wouldn't worsen. Next is the gastrointestinal bleeding. So this involves bleeding anywhere in your digestive tract, which is very dangerous. So imagine that inside your body there's a bleeding, and since it's inside, you can see it from the outside. So you need to operate this when you have this disease. So basically, if the level of acid in your gastric juices is too high, the mucus in your stomach may stop being effective. So excess acid in our stomach is very, very dangerous. Next is, how is acid being reduced? So there are several ways to reduce your acid, which is, first is there's acid reducing medication or meditation, such as drugs where you could intake to reduce your acid, or you need to avoid foods that causes acidity, such as tomatoes, coffees, chocolates, etc. Next is acid in our body when you're not sick may be reduced due to lack of vitamins or poor healthy diet, such as you're undergoing stress, you're smoking, you're drinking, which causes for your body to weaken, and may cause your acid to lower down or be reduced. Next is people over 65. So at that age where you're senior, it is very prone to diseases, especially when your body is started to be weakened. For the part 4, we were going to discuss of how desalination works. This video is a presentation of the desalination plant. Desalination plant is the buildings or the places where desalination process works. So what is desalination anyway? So over all the centuries, scientists had sought ways of removing salts from water, seawater, because as we all know, seawater is composed of 96.5% of our entire Earth surface. So it is a very, very large scale where drinking water is somehow limited for everyone to consume. That's why desalination is a process by which the dissolved mineral salts in water are going to be removed, and to produce this, or we're going this is a process where changing, or where it's a process of undergoing the salt water to turn into a consumable water or a drinking water for everyone to consume. So currently this process is applied to seawater, or it is also one of the most used to obtain fresh water for human consumption or agricultural purposes. Water desalination was used particularly on boats and submarines to provide the crew with fresh water during their long trips. However, this process was not available on a large scale, because until the Industrial Revolution, and especially not until the development of the desalination plants. So you could imagine that we need to boil the water to remove its impurity, so that we could be safe to drinking it. So since after I taste the seawater before, it tastes really, really salty, and it's not very healthy for people to consume daily. What is the desalination process? First is the reverse osmosis. It is the most used process and consumes less energy than the rest, as it is based on the use of semi-permeable membranes. Semi-permeable membranes is in the middle between the low concentration or pure water and the brackish water or the seawater, which is the high concentrated ones. So as we all know, the concentration changes as there is a presence of large amount of salt, while the pure water has low concentration because it is much more pure. We could say that these membranes are made up of ultra-thin polyamide, which can become contaminated with bacteria, so the water must be threatened. So since seawater is very dangerous because it might contain some bacteria, we need this process to cleanse water that turn into something that we could consume. So water is taken from the sea and undergo a process to eliminate the impurities, the oil, the seawater, the dirtiness, and stuff. So after filtering, we have two streams, which is the one with the brine, that one with the high concentration, and the pure water or the fresh water with a low concentration. The brine will gonna be removed, and the fresh water will gonna undergo other process as well, such as remineralization and chlorinization process, so that it is very safe to be consumed and will gonna be stored in a tank for a large scale uses. Next is the solar distillation. So it is imitating the water cycle. It imitates the water cycle as it consists of evaporating the seawater in a large facilities with roofs where it is condensed and collected as a fresh water. So here, as you can see here, there is an inclined transparent lead where where the sun will gonna passes through this is the water, so this is the sun. So the sun is directly proportional to the water, so the dirty or the contaminated water will gonna remain down there. So it is similar to sedimentation, where the solid particles will gonna settle down while the liquid will gonna remain up. So although the energy used in the sun's heat, there is a large areas of land that are required. So somehow it is limited because it could only be done to a large scale areas. Next is the electrodialysis. So as you can see here in the picture, it consists of moving the salt water through electrically charged membranes that trap the salt ions dissolved in the water, allowing fresh water to be extracted. So it requires electricity. So it's kind of similar to putting, which can allow to extract the fresh water. There are diverse variants of electrodialysis, such as conventional and reverse. So in here, you can see here that there is the diluted solution in the middle, and then putting electricity means that there is a positively charged, which is the anode, and then the negatively charged, which is the cathode. So there is also the concentration, where it will gonna affect the concentration in the anode part, in the positively charged, while the concentration in the negatively charged will gonna be affected as well. Next is the nanofiltration. Nanofiltration is the process that uses nanotube membranes with higher permeability than the reverse osmosis ones, which allows more water to be processed in less space using less energy. These membranes are manufactured with sulfonated compounds, which in addition to salt, eliminated the traces of pollutants. So here, the nanofiltration, as you can see, so it's similar to the filtration using nanoparticles. Next is the gas hydrate. So gas hydrate are solid particles that are formed by combining water with a gas, such as propane, and a high pressure and a low temperature. During the process, all the salts and impurities present in the water will gonna disappear, and as the temperature increases, the gas can be recovered, leaving fresh water. So gas hydrates are solid crystals that are formed by combining water with the gas. So solid crystals that combining water with the gas, putting it inside a container with a high pressure but in a low temperature. During the process, all the salt and impurities present in the water were gonna disappear. So all the presence in the water were gonna disappear. The water will gonna be removed, and as the temperature increases, the gas can be recovered, leaving the fresh water. So in here, as you can see here, there is presence of potassium, sodium, calcium, magnesium, sodium inside the container, and there is the gas particles, where the gas particles will gonna dissociate and will gonna become a water, or will gonna become a fresh water. So similar to the experiment that we conducted before about the balloons, the carbon dioxide gases passes through the balloon, and after a few minutes, that carbon dioxide gases turn into liquid. That's all for my presentation. Thank you very much. Have a great day.